In this lesson, we want to see how straight lines can be used for conversion of units and currencies, for simple interest, for travel graphs, and to show a profit and loss transaction. We begin by looking at the conversion of Singapore dollars to Malaysian dollars. Given the conversion, 100 Singapore dollars is equals to 250 Malaysian dollars. We begin by labeling the axis. The y-axis is the amount of Malaysian dollars and the x-axis is the amount of Singapore dollars. The conversion rate can be thought of as a single point with the x value 100 representing Singapore dollars and the y value 250, the amount of Malaysian dollars. We complete this with a straight line passing through 0, 0 because 0 Singapore dollars would give 0 Malaysian dollars. In fact, the exchange rate is also the gradient. That is, for $250 for every Singapore $100, which works out to be $250 for 1 Singapore dollars. And every point on this line shows the conversion of the amount from Singapore dollars to Malaysian dollars. X value representing Singapore dollars and the Y value representing Malaysian dollars. This line has an equation y equals to 2.5 times x. 2.5 is the exchange rate and x the number of Singapore dollars. The exchange rate times the number of Singapore dollars would give you the Malaysian dollars. We next take a look at the amount in a bank over a period of years. If we put in an amount of $500 with a bank rate of 5% per annum, the interest per year will be 5% of the principal, which is $25. And over a period of T years, the interest will be 25 times T. Again, we begin by labeling the axis. X-axis as the number of years, Y-axis as the amount. The fixed amount or the principal is the y-intercept. And from the y-intercept, we need to draw a gradient showing the rate of interest. As we know, the rate of interest is $25 per year. When we draw this triangle, it will be too small. Thus, we have to enlarge the triangle by drawing a triangle representing 250 for every 10 years. This is the same as saying $25 per year. From the y-intercept, we draw a base of 10 and a height of 250 to represent the gradient or the rate of interest. We complete this by drawing a straight line, and the equation of this line is y equals 25x plus 500. Y is the amount and 25t is the interest over a period of t years plus the principal. Amount equals interest plus principal. And once again, every point on this line will show the number of years and the amount obtained for that year. We now take a look at a travel graph. A travel graph is used to represent the journey of a car, and this is represented by a distance time graph. It is important to read through the whole sum and pick out the important information before we begin the sum, such as distances between the town and the starting and ending time of the journey. We begin by marking the beginning and the end of the journey. Town A and C are 120 kilometers apart. And we start at 10, ends at 1:30. Thus, for the x-axis, we show the beginning time 10 and the ending time 1:30. A car starts at 10 and travels at 80 kilometers per hour. The speed here is the gradient. Thus, we draw a triangle representing the gradient from the starting point, 1 hour and 80 km, the height, which represents the distance. This is simply 80 km over 1 hour, or 80 kilometers per hour, represented by the triangle. After 40 km, he reached town B. He traveled at 80 kilometers per hour for 40 km to reach town B. Next, he rested for 30 minutes. This is represented by a flat line because it does not gain in distance, but the time still continues up to 30 minutes before he continued his journey, and he reached town C at 12:12. We need to estimate the time 12:12 by looking at the number of parts. 5 parts represent 30 minutes, therefore 2 parts represent 12. Thus, his destination is at 12:12, and then he starts to travel back to reach town A at 1:30. This is represented by a line going in the opposite direction from town C to town A, reaching at 1:30. And if we need to find the speed of the return journey, again we draw a triangle under the line showing a height of 120 kilometers and a base of 1.3 hours. And the speed is distance over time, 120 over 1.3, giving us 92.31 kilometers per hour. In the last example, we want to take a look at the profit and loss of selling cakes. Mrs. Tan made some cakes to sell. It cost her 50 cents to make a cake, and her startup cost is $600. The startup cost is the cost of equipment and raw materials. Again, we begin with the y-intercept, which shows the fixed value or the fixed cost or the startup cost. The cost of each cake is simply the gradient of the cost line. This can be represented by a triangle. Once again, 50 cents is too small to indicate. Therefore, we are looking at $500 per 1,000 cakes, which is the same as saying 50 cents per cake. And we draw our triangle from the fixed value, the y-intercept, base 1,000, and height 500, which simply means $500 for every 1,000 cakes sold. We complete this with the cost line. In the same way, the selling price is also the gradient of the line showing the selling price. Once again, 150 is too small. We used $1,500 for 1,000 cakes and draw our triangle from the origin, because 0 cakes will cost $0. We draw a base of 1,000 and a height of 1,500 and complete this with the selling line. Next, we take a look at the graph in more detail. In this case here, you can see that the cost price is above the selling price. This will result in a loss. As we move the points, we will reach a point whereby there is no loss and no gain. This point is called the break-even point, where the cost price equals the selling price. Beyond this point, you will notice that the selling price point is now above the cost price point. Therefore, we have made a profit of $179.60. We can draw a line to show the profit being obtained by the selling price minus the cost price. And if the selling price is higher than the cost price, we will make a profit. And if the cost price is above the selling price, we will make a loss. The difference between the y value of these 2 points will give us the profit or the loss. This completes the lesson on application of straight line graphs. Thank you.